happy October. It's October already. I know. So looking ahead this week. So today we're going to do some adding and subtracting of fractions. Tomorrow we'll continue with adding and subtracting fractions. Wednesday we're going to multiply fractions. And then we'll have some practice and another formative this week, Thursday. And then on Friday, we'll add and multiply and make you think and make you look, and so that you're not just doing the same thing. And then next week, we'll start reviewing for our Unit 2 test. Right now, we're tentatively looking at this following Monday. Mrs. Hill and I have a pre-algebra meeting this afternoon, and so right now we're looking at the 16th. It's a Monday that we would take a test. Okay? So that's what we're thinking right now. But that might change, but we'll let you know tomorrow. Yep. All right, so here we go. Let's do this. Let's start adding and subtracting fractions. Okay? So if we have the same denominator, we can add and subtract them relatively easy. Okay? So if I have 3/10, so now this fraction bar is broken up into tenths. There's 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 parts to that one. So if I have 3 of them, let's make that one be blue. Right? So if I have 3 of them, I would fill in 3 of those parts. Right? Then if I add to it another 4/10, that means I would start from where I left off. 1, 2, 3, 4. So we have that many. So altogether, how many parts of our tenths do we have filled in? We got 7 of them. So this would be 7/10. And that's all nice and neat and easy. Anybody see a pattern there in 3/10, 4/10, and 7/10? What you got? Oh, you can't go wrong if you see a pattern. Okay. Well, I'm not asking right or wrong. I'm asking for a pattern. You know, like they both have 10, or all 3 of them have 10. That's a pattern. 10. What? What about 10? All 3 of them have 10, right? So what I just said? Right? Right, buddy? Okay? All right, so anybody else see a pattern? Anybody else see a pattern? You sure? Or I shouldn't even, let's not say a pattern. Pattern might be a bad word. Anybody else see something that's true? They all have 10, and that's true. They're all over 10, that's true. Anybody else see something? What do you got? No, you can't be wrong when you're seeing these things, ladies and gentlemen. What do you got? What did you see? Tell me what you saw. So you just had an aha moment, and you're not willing to share it with the entire class because the off chance that you might be right. Is that what you're telling me? Because you don't want to look like a schoolie, right? You want to look like a nerd. Nerds are cool, okay? Nerds are the coolest, okay? So we're not going on until somebody sees me something that's true, other than the fact that they all have 10. Odd, even, odd. That would be a pattern. Okay? We have an odd, and then an even, and then an odd. That's a pattern. Okay? Anybody else see another pattern or a truth statement? What do you got, Princeton? Yawned at the wrong time.
Anything?
What? Anything. Yeah.
The colors are blue.
Okay, but that's not going to necessarily be a truth statement, though. You know what I mean? We're looking for a number truth statement. They're what? Okay, they're both, all three of them are one-digit numbers? What? Yeah, they are. Yeah, because it's 3, 4, and 7, right? Yeah, yeah. Hey, count. You have to. Yes. Okay. Right. What else? What did you see? What do you mean? They're not mixed numbers, they're just straight up regular fractions? Okay, that's helpful. Okay, that's very helpful. Anything else? Anything else? There is one truth statement in here. It's kind of hidden, but it's also hidden in plain sight. In plain sight. What do you got? They're all positives. Yep. Okay. Truth statement hidden in plain sight. What? It's hidden in the fractions. And it's going to be the key to today. What? What about the addition symbol? So give me a true addition statement that is hidden in this fraction. Keep going. Okay, but that's I need something that's hidden in there. That's what this statement actually is. So what's the hidden truth statement? 3 plus 4 is 7. 3 plus 4 is 7. Is the hidden truth statement. Okay? Hidden truth statement right there. 3. 1, 2, 3 plus 1, 2, 3, and 4 is 7. Okay? That's how we're going to do fractions today. And we're going to add fractions. We're going to find that hidden truth statement, and we're going to use that to be experts at fractions by the end of the day. Okay? What happens here when we've got different denominators? Now they all don't have tens. Okay? So the top bar is divided into 5s. So we would have 2/5 would be that much, right? Now luckily, the fraction bars are the same, or the overall length of these two bars are the same. So 2/5 up here is how many tenths down here on this line? It's 4/10 because it covers this same space. Okay? So there is my 2/5. Okay? Now, can I put 3/10 up on the upper line? No, it's going to be kind of hard to do, right? Okay? But I can put 3/10 on my lower one, and I can add it right at the end. 1, 2, 3. There's my 3/10. So all told, how many tenths, because that's the one where we got both fractions on, how many tenths are there? There's still 7. Yep, there's still 7. Because we've got 1, 2, 3, 4, 5, 6, 7. So this is also 7/10. Now in the last one, we found a hidden truth statement. Our hidden statement up above was 3 plus 4 is 7. Can I say that here? No, I can't. Because 2 plus 3 is how much? 5, not 7. Okay, so I can't just straight up add those. Okay? So there are some steps underneath that fraction bar. These are the steps that we are going to do to add mixed numbers or fractions. Okay? So the first step, as always, we've had it done for us in the first example, and it wasn't done for us in the second example. But what we have to do is we have to find first a common denominator. Okay? The very first thing that you have to do is you have to find yourself a common denominator for your two fractions. You have to get equivalent fractions, is what we're trying to get to. Okay? Then, what we're going to do is we're going to rewrite each equivalent fraction using that common denominator. Once we have them written as equivalent fractions with a common denominator, like example number 1 today, then we can add or subtract the whole parts and add or subtract the fractions. So we're going to add or subtract the whole parts, we're going to add or subtract the fractions, and then we're going to make that be into our new number. The kicker is we're going to keep the denominator the same. Okay? So we want to keep that common denominator, We're not going to change that yet. Okay? I know, I hear you. It seems like it's a lot of steps, but really it's not. Okay? I know. Reduce the fraction last, because we always want our fractions in reduced form. All right, let's do this. Let's do this with number 1 and number 2, and then we'll turn the page, and then it'll be numbers 3, 4, 5, and 6. Okay? All right. So the first question you have to ask yourself is step number 1. Do I have a common denominator? Meaning, are these two numbers down here, are those the same? No, they're not the same. Okay? So those two numbers aren't the same, so we have to do step 1. Using your multiplication chart or using your brain, what is a number? Doesn't have to be the smallest one. Prefer the smallest one, but it doesn't have to be. What is a number that both 2 and 3 go into? 6? Okay, I heard 6 first. Do we agree that 6 can be evenly divided by 2 and evenly divided by 3? Yep, okay. So 6, ladies and gentlemen, is going to be your common denominator. So we write it like that. We write it in common denominator form already, ready to go. Okay. Now, what you've got to do is you've got to make an equivalent fraction for 1/2. So 2 times what gets me 6? 2 times what? 3 gets me 6. So that means I've got to multiply this 1 on top by 3. What is 1 times 3? 3. So this would be 3 6. 1/2 is the equivalent fraction to 3 6. Okay? Haven't changed my problem. I'm just rewriting my problem. Okay? Then you got to go over here to the 1/3. And you got to say to yourself, what times 3 gets me 6? 2. So I got to multiply the top here by 2. 2 times 1 is 2. Okay? No negotiations in this. You have to show that step. Everybody has to show that step. Non-negotiable. Okay? Okay? Everybody's got to show that step. Now, step number 2 says, we did step number 2, we just rewrote it. Step number 3 says, add or subtract the numerators. Right? So we're adding or subtracting the tops. 3 plus 2 is 5. What does the bottom stay? Stays 6. It stays my common denominator. Okay? Is 5 6, this is step 4 now, is 5 6 a reducible fraction? No, it's not. There's no common numbers that go into 5 and 6, so that is your answer. LCD would be the least common denominator. So in this case, our LCD was 6. It was our common denominator. If you go with the least common denominator, the LCD, then you don't have to reduce at the end, potentially. If you go with another number that both 2 and 3 could go into, like 24, then you'll have to reduce at the end. Okay? Excuse me. Number 2, 3 and 6, are they the same? My denominators, are they the same? No. So what's the smallest number that both 3 and 6 go into? So 6 is the number, so 6, yep. So 6 is my least common denominator. Now here's the kicker. We already have one of them as a 6, right? So this one doesn't have to change at all. It's already in your common denominator form. Okay? So that you might only have to adjust one fraction. Back over here, we said that we had to multiply 3 by 2, so then this one would be 4. Agreed? Okay. Add the tops. What do we got for the tops? 9 6. Neither one. Do I like 9 6? Why don't I like it anymore? So the top is bigger than the bottom, which means we could bring in a mixed number, right? Okay? That's one reason why I don't like 9 6. What's another reason why I don't like 9 6? Oh, yeah? Okay, we don't like it because top is bigger than the bottom, for one. What's the other thing? I don't like 9 6. Did we follow all of our steps that we just described up in the middle of our page? We did. We didn't reduce it. We didn't do step number 4. Is there a number that can go into both 6 and 9? 3. So I could divide this by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Do I like 3 halves more? Do I like 3 halves more? Yeah. Yes, I love 3 halves more. Now let's go here. Is my top still bigger than my bottom? Yes. So what is my alternative in reduced form? My alternative mixed number. 1 and 1/2. Nine 6 or 1 and 3/6, the 2 original answers that you gave me, would both be marked wrong. Right? Because they're not reduced. You didn't do step 4. Okay? All right, turn page. Subtraction problem now. Okay? Same steps. Okay? Do we have a common denominator? No, we don't. What is my common denominator between 2 and 3? 6. To multiply 2 by what? To get 6? Multiply by 3. So then this one would be 3 6. Multiply 3 by what to get 6? 2. So then this one would be 2 6. When we did this problem 5 minutes ago, we said now we're going to do 3 plus 2. But now we subtract. So what's 3 minus 2? 1. Okay? 1/6 here then. Is 1/6 reducible? No. No, it's not. Okay? So that then is your answer. On the front side of this page that you're writing on, about 3 minutes ago, you told me that 6 was the common denominator, and that 2/3 is the same as 4/6. Right? You guys just told me that front side example number 2. Okay? So now, instead of adding, now we're subtracting. 4 minus 5. -1. Okay? We have to carry that negative sign into the fraction. And for us, we're going to put it on top. Nice and clear so that it's not, we don't get it confused with part of the fraction. Can that fraction be reduced? No. Okay? So what I would like you to do now is I would like you to do the next 3. Okay? So you're doing those 3. Go. Two-thirds is how many 12ths? 8. Because I multiplied 3 by 4 to get 12. So I got to multiply the top there by 4. 3/4 is how many 12ths? 9, so I got to multiply by 3 to get that. 1/6 is how many 12s? 2, so I got to multiply by 2 there. Okay? 8 plus 9 plus 2. 19? We agree with 19. Okay. Can that be reduced? 19 over 12?
No.
Reduced is different than mixed number. I'm guessing you were going to say 1 and 7/12? Yep, that's mixed number. Okay? Reduced would be going from like 9/6 to 3/2. Okay? So it can't be reduced, so we could leave it like this, or 1 and 7/12. Okay? Number 6, you told me the common denominator was 10. Which means that second fraction doesn't have to change. What does this first fraction become? 4. 4 minus 3 is 1/10 there. And that can't be reduced. Alright? Let's spend a little time here doing number 5. That one's our first mixed number and fraction type one. Okay? So in my brain, I'm going to take this 3 and I'm going to just move it right out here. I'm going to put it out in front. Okay? I'm going to remove it from the problem. Okay? Since we're adding, we're okay with that. What Jesse was saying was you were going to make it be an improper fraction, right? That's an option too. You can make it be an improper fraction, and then you're dealing with 2 fractions just like you have been up to this point in time. Okay? Another way, though, an alternative way, is pull that 3 out in front, and then you just have 7/8 plus 1/4. Okay? 7/8 and 1/4. What's my common denominator? 8. Okay? So this first one doesn't have to change. What does 1/4 become in eighths? 2 of them? 2/8 there. Okay? 7 plus 2. That becomes 9. Now here, you have to make it, because this 3 is still being added to that, we have to make 9/8 into a mixed number. Okay? 1 and 1/8. Okay? What? Because 8 goes into 9 one time with a leftover of 1. So it's 1 and 1/8. Okay? And now these 2 get added together. So my final answer here is 4 and 1/8. Now, if, Jesse, you had said way back at the start, can I get him perfect? I can close enough here. Okay? You said you had changed this one to 7/8 plus 13/4. Okay? So if I change 3 and 1/4 to 13/4, I get that. then this would be 26. Which would be 4 and 1. Okay. So either way, okay. Alright? So if you haven't turned in the B5 homework, that one's due. Lots of you turn that one in though on Thursday during our work day. If you haven't turned in your green formative, that one's due. And then I am about to give you a B6 fractions adding and subtracting homework.